First, let's create a new file. We will create function main, and inside our main we will create one variable with data type float64. Let's now see which floating formats we have. These 5 formats define how we will see our output when we print our floating points. If we print our variable with %v, we will get whole number in our output. Let's now see the cases if we use %f operator. In this case, left side of our dot will be exactly the same as our number, but the right side will have only 6 decimals. Why? Because default precision is 6 numbers. In this case, left side will be still the same, but right side will now have 5 decimals. Why? Because in our %f format, we specified that we will have after dot 5 numbers, and our precision now is 5 decimals. These 4 examples will have the same output. How is that possible? We specified that we want 2 decimals in our floating point. And yes, in all examples, we have 2 decimals. But the question is, how left side is the same when we put 2, 5, 9, and 10? On the left side of our dot, we defined our width, which means that in these cases, we are expecting at least that amount of numbers in our number which we are printing. So, in this case, our output have exactly 10 characters. How? Well, we have 7 numbers on the left side. Dot we are also counting as character, and we have 2 numbers after dot. So, that's how our width is equal to 10. What if we breach that 10 width and we write greater number? Let's see practical example. Now our width is 11 and 12, so we breach our maximum width, which means that in case when we put 11, we breached one place. Our format will write one empty place in front of our number. In case where we put 12, we breached our max width for 2 places, which means that our formatting will write 2 empty places in front of our number. In these examples, if we don't put number for our precision, we won't have decimal numbers. In the last case, when we put width 9, we breached our left side of our point for 2 places, which means that for the last number, we have whole left side of our point, but we breached our max width for 2 places. So we will have 2 empty places in front of our number, and still we won't have decimals. You can save file and execute program in our terminal, so you can see whole output. After you finish that, let's now see how we can organize our space in our formatting. Let's now create new file. Let's say we want format like this. We need 3 straight lines and we need 6 places between those lines. How we can do that? Here in printf function we have operator %s, which will print for us string data type on that mapped places. But as you can see, we have number 6 between sign % and letter s, which means that on that location we want to reserve 6 places for our variable. In this case, our output will look like this. As you can see, we have three straight lines, but between those lines, we have 6 reserved places for our printing variable. Also, you can see that our printing values are on the right side of that space. In this case, as you can see, we put minus character in front of our number, which will be number for reserved places. That's how we print our values on the left side of our reserved space. In this example, we can see that we can also do all this with operator %d, and pattern for printing is the same. Also, we can specify %f operator, and we can type which precision we want for that format. Pattern for formatting is still the same, like %s and %d. Now we understood how we can better format our printing output and how we can organize our space. Let's save our file and create new one for our conversions between our data types. As you can see on start, in import section, we have fmt package, but we have also reflect and strconf package, which we want to use from our Golang core. They will help us with our conversions. For start, we created new variable with data type integer. Our task is to convert this variable to float64 data type. We will declare new variable, let's say f, and now we will define which data type we want to use. So we want to convert in float64. So we will type float64 and then we will write brackets. Inside of our brackets, we will specify declaration, which means the name of variable which we want to convert. So in this case, that will be variable e. This means that we convert our integer data type to float64. For new variable u, we specified that now new variable will be converted to unsigned integer, and we want to convert variable f. This means that we will convert float64 to unsigned integer. Now, if we use printf function and we write each type and value of our variables, we will get this output. First variable will be data type integer with value 42. Second will be float64 with value 42.00, and third will be unsigned integer with value 42. We can also print our types and values of our variables with reflect library. In these examples, we use a reflect library. When we access reflect library, we call typeOf function and we pass our variables. In that case, that function will return us type of that specific variable. Now we can save our file and execute the application. But before we do that, let's talk about one thing. As you can see, in our import section, we specified that we want to use strconf library. But there is one problem. We didn't use that library anywhere in our code. So what happens now? If we now save our file, we will see that strconf library will be deleted from our import section. We can save our file on Ctrl S. Why this library is deleted from import section? Because our environment recognize that we didn't use anywhere in our code that library, and in that case, if we leave that library in our import section and try to run our application, we will get an error because our language will tell us that we specified library which we didn't use anywhere. For the future, know this. don't write and don't import unnecessary libraries which doesn't have purpose for you. Eliminate all wasted code so your code can be clean and easily to read. Because we are saved our file, now you can execute our application to see the output. In the next video, we will talk about if and switch statements, how we write them and where we use them.